Hi, my name is Levent Akbars. I'm the Chief Commercial Officer at Handmade Materials. Handmade Materials is a technology company. We develop and produce the materials that you can print in ColdMetalFusion. ColdMetalFusion is a process chain that allows you to use our materials in an SLS printer, but that enables you to print metal parts on a polymer printer, debind these parts and sinter them in a conventional sintering furnace. Today we have an automotive lightweight gear that we're going to produce, and this is a geometry you can only realize in additive manufacturing. First, we prepare the job. In the CAD software, we finish the part design. Then we increase the size of the part by its shrinkage rate. And then we hand over this part to prepare and fill up the build job. After you're done preparing the build job, you go over to the build module and fill it up with Handmade's material. On the ColdMetalFusion lab system today, you can print 174pH stainless steel and the M2 tool steel. In this case, today we will be using our 174pH material. What's really great now in ColdMetalFusion is it's cold. We can print at 50 degrees Celsius of the build chamber. And this makes the process very stable, and you can reuse all of your powder that you do not print. After we're done with printing, the parts are called green parts. And these green parts have to be removed from the overall powder cake and brushed to really have neat, fine surfaces. Our material is purposely developed for the SLS printing process. And if you would look at this powder under the microscope, you would see little plastic blobs with metal spikes sticking out of them. And when it melts, we fill up all the cavities, and this allows us to get really dense, strong parts that come out of the printer. After depowdering, we take our green parts into the washing station. Here we water blast the parts to take out every little particle that's not supposed to be there. That's how also we ensure a very high accuracy of the parts of 0.1 millimeters. Then, once they are cleaned, we have a nice smooth surface. Once we're done in the green part stage, we use the debinding station and turn the part into a brown part. Inside the debinding station, once the door is closed and all the trays are loaded, we flood the chamber with solvent. What's happening under the microscope is that the solvent is starting to penetrate the walls of the parts and starts to suck out one of the plastic components we have. After a night of debinding, you can take out your parts, and now we call them brown parts. They will now be loaded on another tray and will go into our furnace for sintering. Inside the furnace, we heat up the chamber to over 1000 degrees. As the temperature increases, the particles start to grow together into the final metal part, which is highly dense and has very good mechanical properties. The sintering process takes about 12 to 15 hours. The really nice thing about it is, it doesn't matter how big your furnace is. With ColdMetalFusion, you can start with one part, develop it for the process chain, and then scale up into the millions, and you would still have 12 to 15 hours. Now that we're done, we have a pure stainless steel metal part in our hands. It does no longer contain any residue of the plastics that were being used in any prior steps. Compared to conventional manufacturing, we are on the same level of mechanical performance. The parts exhibit excellent elongation that supersedes the MIM standards with an elongation of 13.2% after hardening. We thank you for your time today looking at the ColdMetalFusion process chain, a piece of technology that allows you to manage porosities, to have free-flowing channels, to get superior mechanical properties. And we think that we are really moving the boundaries of what is possible today.